So it tells us that x lies in the second quadrant, and they're asking us to determine the measure of the angle x. Now, is there a way, I'm going to write the following down now. The cosine of 3 pi over 11. Is there a way that I can rewrite that using one of those co-functions? And I can give you a hint, but can anybody think of a way that I can write that using one of those co-functions that we just talked about? Now, I don't have the page reference in front of me, but just think of all the co-functions and think about the second quadrant co-function that involves cosine, right? So in the second quadrant, what was it that we used with the pi over 2 or 3 pi over 2? Was it 3 pi over 2 plus 3 pi over 2 minus, or was it pi over 2 plus or pi over 2 minus? Can anybody remember what that was for the second quadrant? Can anybody remember what that was? 3 pi over 2 minus, you're saying, for the second quadrant? Not so sure. No. 3 pi over 2 plus for the second quadrant. Okay, let's do a quick quadrant thing here to remind you. Here's my pi over 2 here. Here's my 3 pi over 2 down here. Okay? Now, second quadrant. So it's not 3 pi over 2. You're right. It's pi over 2 plus. Thank you, Brendan. Thank you, Chrisania. Thank you, Donna. Thank you. A bunch of you said the right thing there. Okay. So what I'm going to do is let me first of all erase this. Right? And I'm going to write down the identity that gives us the second function, co-function for this. So I'm going to write that down. Hopefully you're going to remember this from what we did. So according to what we just learned, the cosine, in fact, I write them down for both. I write it down for sine and for cosine. So the cosine of pi over 2 plus theta is equal to the minus sine of theta, right? And also, we learned that the sine of pi over 2 plus theta is equal to the cosine of theta, right? Do those sound somewhat familiar? All right, let me go back and look at what the chat is saying here, right? Isn't that what we just learned a few minutes ago? Remember, because I'm in the second quadrant, oh, geez, hold on. Because I'm in the second quadrant, sine is going to become cosine, but it's going to be positive. Can we agree on that? Let's just see if we can agree on that. Does that make sense to everybody? Okay. I just want to make sure, but there's consensus on that. I see a few people saying yes to that. Perfect. So since we know that the cosine of pi over 2 plus theta is equal to the minus sine of theta, and that the sine of pi over 2 plus theta is equal to, and that's all second quadrant stuff. Both of these are second quadrant stuff. Is there a way that I can rewrite the cosine of 3 pi over 2? Is there a way that I can rewrite either side of this, is what I'm trying to get at here, right? Can I either rewrite the sine of x or the cosine of 3 pi over 2 plus 11? Sorry, what am I saying? 3 pi over 11. Is there a way that I can write either one of those so that it fits into this thing right here? Is there a way that I can do that? Anybody? Can one of these be replaced by one of those? Can anybody give me a clue as to that? Okay, I'll give you an idea. How about this one here? Let me put a little check mark beside it. Right? Look at that statement. Can I rewrite that to help me to solve this? Can I rewrite this then? Instead of saying the cosine of 3 pi over 11. Well, how can I use this statement, right? This statement up here, this statement down here that I put a check mark beside, based on what this says, the thing I just circled. Can anybody? Okay, so let me do it then. So what would the cosine? I'm following what this says. What should, and I write this in black as I had before. what would the cosine, according to this thing here, of 3 pi over 11 be equal to? Right? What should that be equal to? Based on what this line says, the line I just checked off, should be equal to what? Look at where the theta is, right? And I just put in place of theta 3 pi over 11. Does that make sense? Right? So what can I put this as? And I can put this as the sine of what? The sine of what? Think about that, folks. Right? It's on the line right above it. Pi over 2, exactly. So it's going to be the same thing as pi over 2 plus the 3 pi over 11. Because that is what my theta is. Right? Isn't that what the theta is? The theta is a 3 pi over 11. So instead of saying the cosine of theta, I'm going to say the cosine of 3 pi over 11 is equal to the sine of pi over 2 plus 3 pi over 11. Are we all on the same page here? I want to make sure what we're following along here, folks. Right? Let me check in with the room again. Okay, I see a hand going up. Quinn, yes, go ahead, Quinn. Okay, so the question was, can I explain how 3 pi over 11 is equal to theta? Just think about theta as being like an x, right? You know, like when you're solving an equation and you say x equals something, right? So now we're saying x is, Quinn, the 3 pi over 11. So wherever I have what cosine of theta is equal to, I'm going to replace theta with 3 pi over 11. I'm saying that 3 pi over 11 is x, or in this case, is theta, right? So I'm putting 3 pi over 11 wherever I have theta. So that means that the cosine of whatever theta is, which we're saying is 3 pi over 11, is going to be equal to the sine of pi over 2 plus that same value of x, or theta in this case, of 3 pi over 11. That's what we're saying. Does that kind of make sense? I just want to be sure now, right? That's sine, right? What did I have? Yeah. Okay, so it doesn't look like sine, but it's supposed to be sine. Yeah. Okay. Okay, Donna. Yeah, you're telling me I can't write very well. That's all right. That's okay. That's okay. All right. Okay. So Quinn, just think about this. We're making a substitution, right? We're just making a substitution. Wherever we saw theta, we're putting 3 pi over 11. Let's put it that way. Can we say it that way? We're plucking out the pi. We're plucking out the theta, and we're putting in its place 3 pi over 11. Does that make a little bit more sense then? Because you're saying kind of. Okay, good. Okay, sure. No, that's all right, Don. I'm not taking offense to it whatsoever. All right. So that's all we're doing. Where we saw theta, we put the 3 pi over 11. So that's what we've done. So now we have a way that we can represent the cosine of 3 pi over 11. We're saying it's the same thing as the sine of pi over 2 plus 3 pi over 11. That's what we're saying. So all we need to do is a little bit more math now. I'm going to take a common denominator. Just think algebra now. Think about, like good old fashioned, arithmetic now. I'm going to say the common denominator here is 22, right? I'm just using the product of these two. And this, if I'm right, should be 11 pi. So 2 times 2 into 22 is 11. So 11 times that is 11 pi. 11 to this is 3. Sorry, that's rubbish. 11 goes into 22 twice. So that's 2 times 3, which is plus 6 pi. Okay. All right. So I'm just doing arithmetic here, folks. Just regular, good old fashioned arithmetic. Let me bring this down some more. So far, here's what we have. That originally we had that the cosine of 3 pi over 11 is actually equal to the sine of 17 pi over 22. We're saying that these two things are exactly the same. Okay? And in fact, what you could do right now is grab your calculator and let's prove it. We're saying these two things are identical, right? That's what we're saying. Everybody grab their calculator. I'm going to grab my calculator as well. Make sure that your calculator is in radians. Let me stress that. If it's not in radians, you're not going to get the right answer. So look for how to convert your calculator into radians. Don't forget that we're now in a radian world. We're no longer in a degree world. So if you're not sure how to convert your calculator over, then you got to look up your manual, right? Unfortunately, I can't tell you exactly how your calculator works because they're all different. There's always a way to convert from degrees into radians. I can show you my on-screen calculator to help you out with that, but it is in fact something that you should be able to do, okay? We have just figured out, and by the way, I want you all, if you're now in radian mode, to double check. Are you getting that the cosine of 3 pi over 11 is the same as the sine of 17 pi over 22? Are we all getting, yes. Chrisania says yes. Everybody else, no, because I want you to get practice with using your calculator in radians and working with pi and all this other stuff. Can you all check that you're getting the two things to be equal? Okay, Brandon is yes, good. Everybody else, where's everybody else? Okay, perfect, perfect. Let's go back to the question. Let's go back to the question. The question says that the sine of x is equal to the cosine of 3 pi over 11. And here's what we found out. That the cosine of 3 pi over 11 is the sine of 17 pi over 22. Now remember, cosine of 3 pi over 11 was equal to, let me move this down some more. The cosine, the cosine, actually I think it was the other way around. I think they said the sine of x first. So I'm going to write it exactly the way they had the question. So the sine of x is equal to the cosine of 3 pi over 11. So what they're asking for is, what is x? What is x? All right, I think we have the answer, folks. Remember, the sine of x is, I'm just going to show it to you again. Question said that the sine of x is the cosine of 3 pi over 11. That's what the question says. We know that x lies in the second quadrant. That's also what it says. Determine the measure of angle x. Well, this is the question. We found out that the cosine of 3 pi over 11, this thing here, is equal to the sine of 17 pi over 22. So these three things are equal. This is equal to this is equal to this, right? So what is that? Brandon is way ahead of us. So x is equal to what? Well, x must be equal to the 17 pi over 22. That's what x is, which, by the way, is a second quadrant angle, right? If the sine of something is equal to the sine of something else, then those two things must be equal to each other. This x here must be equal to the 17 pi over 72 because they're both sine, right? Let me see who that is. Yes, Lynette, please go ahead. Correct, yes. And what they're asking for is what the angle is. What is the actual angle? What you have is the sine of the angle. That's what the question, that's what the calculator is showing you. The calculator isn't showing you the angle itself. It's showing you the sine of the angle. When you press the cosine of 3 pi over 11 or the sine of 17 pi over 22, you're getting what the sine of the angle is or the cosine of the angle is. You're not getting the angle. The angle is actually 17 pi. That's the answer. The answer is 17 pi over 22, which is not 0.6, whatever it is that you got. Okay? Does that make sense? Are we good with that? No, Lynette says perfect. Okay, so there's your answer, folks. There's your answer. All right. So we just used a co-function identity to answer that question. Now, I am going to try one other question, which is very similar for us to solve for C in the next question. After we're done that, and we'll move on to, and we'll take a break. We'll take a break after we finish this. Then we'll move on to the compound angle stuff. And at that point, because we're still in the week where they're saying you no longer have to be here, you're welcome to go away and do whatever you want to do. Hopefully it's schoolwork, and watch the video later on. That's totally up to you. I'm going to be inviting you to stick around though and work with me, ask me the questions as we go along, but that is totally up to you. As of next week, we go back to the normal format. Okay, so what I'm going to do now is tackle this other question down here. The sine of 4c minus pi over 4 is equal to the cosine of 2c plus pi over 4. It's going to be a similar. Oh, and by the way, although the question doesn't say it, they only want answers in the first quadrant, and I should make that point. The x that we're looking for is less than or equal to pi over 2, greater than or equal to 0. So somewhere between 0 and pi over 2. So we're necessarily talking about a first quadrant answer. So I'm just wondering, last time when we had something like this, it was where sine and cosine were involved, right? So we had to convert one side into the same as the other side for us to be able to set them equal to each other, right? What's that Brendan saying? I've been signed up. Okay, Brendan. Um, so maybe there's something similar to that that we can do here. Maybe we can take one side of this equation and make it become either cosine, so they're both cosine on either side, or we can take the cosine side and make it into a sine so that we have sine on both sides. That's what these cofunctions allow us to do. Cofunctions will allow us to change from sine to cosine or from cosine to sine. Also, of course, changes from cosecant to secant and tangent to cotangent, all that kind of thing. So I want you to try and think of how we might be able to use what we just learned, right? And we just applied in that question to this question. Now, let me remind you, I'm going to write down the two cofunctions that we have for the first quadrant that involves sine and cosine. I'm going to write them down for you. So the sine, I don't know why I'm using red, of pi over 2, is it going to be minus x or theta, I should say? Is it going to be minus theta or plus theta? Remember, we're dealing with the first quadrant here. Remind me, folks. If it's in the first quadrant, am I going to go plus theta or minus theta? I kind of gave away the first part. It's going to be pi over 2 plus or minus something. So it's minus because it's in the first quadrant. Good. So pi over 2 minus theta is equal to the cosine of theta and also the cosine of pi over 2 minus theta is equal to the sine of theta. So again, one is changing to the other if it's a cofunction. Only when you're deviating from the y-axis. The only change when you're deviating from the y-axis, not when you're deviating from the x-axis, deviating from the y-axis. Yes, Lynette, please go ahead. Or is your hand just still up from before? Okay, all right. All right. Okay, so could we use one of these to change from sine to cosine? Is that possible? The answer, of course, is yes. Can you think of how that might look? And I'm going to say that the last time it made sense for us to deal with the side that had the cosine on it and make it and use it equal to the sine of pi over 2 plus theta. That's what we did in that case. But in this case, I'm going to say that we could use either side. We could use either one of these, as long as at the end of the day, we have all either sine or all cosine. Now, I'm just going to arbitrarily choose one of them, right? So again, this is a totally arbitrary way to do it. I'm going to just arbitrarily say we can use the first one. How can I now express the cosine of 2c plus pi over 4, right? Help me to express that. You can just unmute if you like, or you can put it in the chat. Either way, how can I express? Okay, so let's see what Kelvin says now. So since the cosine of theta is equal to pi over 2 minus theta, and the theta represents theta, then that would mean cosine of 2 would be replaced with the sine of pi over 2 minus all of that stuff. Oh, well done, Kelvin. Look at what Kelvin just said, because that's exactly what I'm about to write down. Read what Kelvin just said, right? He is using that cofunction, and the one I checked, and I didn't have to use the first one. I could have used the second one, by the way. But we're going to take that cosine of, this is now my theta. All of this is my theta. Everything in this bracket is my theta now, right? So remember when we were doing this before, Quinn, when we said that theta was, I think it was 3 pi over 11. Now theta is going to be 2c plus pi over 4. All of that's now going to be theta. And that's equal to the sine of, exactly what Kelvin just said, pi over 2 minus all of this stuff. Except I'm going to put a second bracket inside because I'm minusing all of what's inside of that. So 2c plus pi over 4. Okay, So I'm just simply applying the cofunction to change it from cosine to sine. I want to be sure that everybody is with me. Kelvin obviously is fine with that, but I want to make sure everybody else is at. Hunayan, how about you? Does that statement that Kelvin just made and what I just wrote down, does that make sense to you as well? Hunayan, how about you? Where's Hunayan? You perfect. Okay. So let's continue with this. Let's just do the math on this now. So that's equal to, right, the sine of, now we're going to have to take away these brackets, pi over 2 minus 2c minus pi over 4. All right, don't forget that I'm minusing everything inside the bracket. Everything is being minused here. All right, so pi over 2 minus 2c minus pi over 4. So we need to do some math here, right? We need to do some math. Let's put together these two things. And so far, we're at the point where we took the cosecant of, in fact, I'm going to move this whole thing over here. Let me just take this whole thing, move that over, and remind you that all of this that we are now writing as the sine of pi over 2 minus 2c is the same thing as the cosecant, what we had initially, as the cosecant of 2c plus pi over 4. Right? That's what all of this was. We just made it equal to something else, but these two things are exactly equal to each other. The cosine of 2c plus pi over 4 is equal to the sine of pi over 2 minus 2c. Now, I want you to remember what they told us in the first place, right? That this cosine of 2c plus pi over 4 was equal to the sine of 4c minus pi over 4. Okay? Right? So we just changed the cosine into a sine, into this thing that is now a sine. So since we have originally that this was the cosine of 2c plus pi over 4, that's also equal to the sine of 4c minus pi over 4. So I'm going to say that all of this is equal to, all of these three things are equal to the sine of 4c minus pi over 4. Right? All of these things are equal to each other. Okay? Yes, Quinn, go ahead, please. Oh, okay, yeah. Yep. Mm-hmm. Sure, absolutely. So Quinn just is asking me to go over how we got to this place here. So I'm just going to go over, I'm going to start off, in fact, I'm going to go all the way back to this line right here that I'm pointing to right now that I think you can see my cursor, it moves across the screen. I'm going to start from that and then go back to the point that I'm at right now. Do you think that will help a little bit? Do you think that should be okay? Okay, good. All right. So originally we said that the question said that we're trying to solve for C, by the way. That's what we're really ultimately trying to solve for. And our C has to be in the first quadrant. I didn't put that in the question initially, but we're saying C has to be in the first quadrant. So I repeated two of the first quadrant cofunctions, that the sine of pi over 2 minus theta is equal to cosine of theta, the cosine of pi over 2 minus theta is equal to sine of theta. Those are those cofunctions that we are saying are true. So I'm now saying that I could take the cosine of 2c plus pi over 4, call this thing here my theta. Let me circle it in red. This now is my theta, or what is it, yellow. This is my theta now, right? So I can use that with the thing I just put a check mark beside and say, instead of saying cosine of theta, I'm saying the cosine of the yellow circle is equal to the sine of pi over 2 minus this yellow circle, which is the same yellow circle I have in the first one. So the 2c plus pi over 4 is my theta. So I did kind of skip a step a bit. I must admit I did skip a step. This second thing here, pi over 2 minus the 2c plus pi over 4, I'm just simplifying it a little bit. So making it pi over 2, well, actually, this is just removing the brackets. So since I'm minusing the 2c and I'm minusing the pi over 4. Both of these two things are being minused. So far, so good for that line, just to make sure that everybody's okay with that. Not just Quinn, but everybody else. Does that line make sense? Brandon says yes, okay. And Donna is raising a hand. Okay, Donna, go ahead, please. I did. Yes, I did. Yeah. And you're welcome. So she's just asking if I distributed the negative into the bracket, and that's exactly what I did. I know the question would not be audible on the recording, so I just wanted to repeat the question. So I'm minusing the 2c and minusing the pi over 4. Here's where I did skip another step, which is I took the pi over 2 and I minus pi over 4 from it. I put those so-called like terms together. This is a half minus a quarter, and I think we can all accept. Did I write that down wrong? Sine of pi over 2. Oh, this is wrong. Yeah, how is that still pi over 2? Nobody called me on that. That's not pi over 2 anymore. This is pi over 4. Yeah, yes, that's probably what you were totally confused about. You're confused over the fact that I'm making up stuff. That's what I mean. That would confuse anybody. Hang on a second. That was wrong. whatever how you spell wrong. That's pi over 4, folks. Right? That was wrong. You take a half and you minus a quarter from it, right? You can do that on your own, but a half minus a quarter is certainly not a half anymore. It's a quarter. So it's a quarter minus 2c. So that would have been wrong. And therefore, we're going to change a couple other things here. So what is all of this here? Hold on. What am I doing? What is Mr. Kamak doing? That should have been pi over 4. Okay, so okay, all right. So I think that's the only thing I need to correct now. So Quinn is right to call me on that because what I had before was wrong. It's actually pi over 4. So I took pi over 2 and I minus pi over 4 from it. This pi over 4 minus 2c. So that's still, now remember that was what cosine of 2c plus pi over 4 was. We just changed it into a sine. But that's also equal to this thing down here, which is 4c minus pi over 4, because that's what the question said in the first place. The question said that this thing here was equal to the sine of 4c minus pi. So everything is equal, right? All these three things are equal. This is equal to this. We use a cofunction to convert from this to this. But the original question said that this that I'm pointing to here is equal to this that I'm pointing to here now. So I'm going to write those two things. I'm going to write all of these things that are equal to each other, but I only want to focus on the things that are sines, because this says that the sine of, and I want to make sure I write it down correctly this time, Quinn, of pi over 4 minus 2c is equal to the sine of 4c minus pi over 4. Right? All these three things are equal. So if they're all equal, then it means that I can now make these two things that are sines equal to each other. Everything here is equal, right? Does that make sense, everybody, so far? Let me know if I did anything that if I made any mistakes as well. Please stop. Yes, Donna. Go ahead, Donna. Yeah, go ahead. Sure. No, I don't mind going with that at all. How did I get the pi over 4 minus 2c? So let me go back to this step up here where I did make a mistake. That comes from this line here. So after we distributed the minus, which you asked me about earlier on, when after I distributed the minus into the bracket, so there is a minus 2c plus pi over 4, I got minus 2c minus pi over 4. Okay? And then I'm just combining the pi over 2 with the minus pi over 4. So what we're really doing, I'm just going to put it on another page here. So pi over 2 minus pi over 4. I'm just putting those two things together. The common denominator is 4. So that would be 2 pi minus pi, right? If you follow me here, right? 2 into 4 gives me 2, so 2 times pi, which is 2 pi. 4 into 4 is 1, so 1 times 1, which is that. So I'm just going to end up with just simply pi over 4. And that's what I should have said the first time, which I didn't, but I apologize. So the answer should just be the pi over 4. That's what's left when you take those two together. Okay? And then you still have them. Yeah. Go ahead. Exactly. It's just sort of like terms. So, and then I still have the minus 2c. And we're just showing that all three things are equal. The cosine of 2c plus pi over 4 is using cofunctions, the sine of pi over 4 minus 2c, which is equal to what we said this was equal to in the first place, sine of 4c minus pi over 4. Now, when all these things are equal, we can now, let's get a little water there, we can now make the very important observation that we have sine on the left and sine on the right. Does anybody know what that means that we can do in the very next line? If the sine of this is equal to the sine of that, does that suggest anything to anybody? Can anybody give me what the next conclusion is that we can draw? If they're both sine, see, what was very important was for us to have sine on the two sides. We started off with cosine on one and sine on the other. Now we're both sines on the two sides. So cancel, when you say cancel, you're kind of on the right track. I don't need the sines anymore, right? If there are sines on both sides, I can now say that the pi over 4 minus 2c is just simply equal to the 4c minus the pi over 4, right? If they're both sines, if the operation that you're taking is the same on the two sides, if the sine of something is equal to the sine of another thing, then those two things you're taking the sine of, those two things must be equal. Okay? So I don't really like the word cancel, but I know what you mean, Mohammed. In a sense, you're saying we can ignore the signs. We can ignore the fact that it's the sine of something in a sense. If as long as they're both sines, if one side was like sine and the other side was cosine, you can't do that. Well, because they're both sines on both sides, we can just say ignore the signs and just make those two things equal to each other. So now we just have a regular, ordinary equation. No more signs anymore. Bring the 2c on the other side and bring that pi over 4 on the other. So I'm going to have pi over 4 plus pi over 4 is equal to the 4c plus 2c. Okay, I'm just doing regular, ordinary algebra at this point. So this would give me 6c on this side. This is going to give me 2 pi over 4 on this side. Excuse me. And then all I need to do now is divide both sides by 6. So how do I divide by 6? Well, it's very simple. I multiply by 1 over 6. So c is equal to 2 pi over 4 times 1 over 6. Another way of dividing by 6 is to multiply by 1 over 6. So if I do the math on that and then reduce it down, well, first one, I'm going to have 2 pi over 24, which of course is just simply pi over 12. Okay? So that would be the value of c that makes that equation work, pi over 12. Okay, Quinn, go ahead, please. Sure, and you will still end up with pi over 12 because pi over 2, you're right, cancel it down to pi over 2, multiply it by 1 over... Oh, by the way, the question that he was asking, can I not just put 2 pi over 4 as pi over 2, which is right, yes, and pi over 2 times the 1 over 6 still gives us pi over 12. So in the end, we still get the same answer of pi over 12. But that's a good question, and that would be the answer. Okay, yes, Donna, go ahead, please. Sure. Is that far up enough? Okay. Sure. Mm-hmm. Mm-hmm. Pi over 4, yeah. Mm-hmm. Okay, good. Because the original question said that. The original question said that the cosine of 2c plus pi over 4, the cosine of 2c plus pi over 4 is equal to the sine of 4c minus pi over 4. So I took it from the very first question. The sine of this is equal to the cosine of that. So since the cosine of that is equal to that, I just have all three things equal to each other here. All three things are equal because that's what the question said initially. Does that make sense? Okay. Correct. You're welcome. Okay, so that's just showing you how we can use these cofunctions to solve equations.